Good morning. Today we will be presenting all the sciences that contributed to the creation of the atomic theory. The first scientist who developed the idea was Democritus. He stated that all matter is made up of small indestructible unto-cold atoms. However, there were scientists who did not believe in him. First are the scientists who did not believe in his theory. And first we have Anaxagoras.
Anaxagoras. He argued that there were infinite number of elementary natural substances in the form of infinitesimally small particles that combined to comprise the different things in the universe. Empedocles. He stated that everything is made up of four eternal and unchanging kinds of matter: fire, air, water, and earth.
So next we have Plato. Not this Plato. Plato.
Plato. He further expanded Empedocles' theory by saying each of the four kinds of matter is composed of geometrical solids or Platonic solids, further divisible into triangles.
And lastly, we have Aristotle.
Aristotle. He believed that the four elements could be balanced in substances in an infinite number of ways, and that when combined gave proportions of essential qualities: hot, dry, cold, and wet. Alchemy. Many of the earliest chemists, physicians, and philosophers were also chemists. The word alchemy brings to mind a cauldron full of images, witches hovering over a boiling brew, or perhaps sorcerers in smoky labs or chattered libraries. Alchemical practice played an important role in the evolution of modern science. Historically, alchemy refers to both the investigation of nature and an early philosophical and spiritual discipline that criticized chemistry with metal work. It encompassed physics, medicine, astrology, mysticism, spiritualism, and art. There are three principles of alchemy, and I'll tell you what they are. First, sulfur, harmony of the air and fire elements. The sulfur principle is reflected as our soul. Second, mercury, composed of the water and air elements. Mercury is the spirit. And lastly, salt. It is composed of the water and earth elements. It is the anchor for our soul and spirit.
So next, we have the scientists who believed the theory of Democritus. First, we have John Dalton.
John Dalton. He was a chemist who published his theory about atoms in 1808. Now, here is Dalton's atomic model. Democritus first suggested the existence of atoms, but it took almost 2 millennia before the atom was placed on a solid foothold as a fundamental chemical object by John Dalton, an English chemist. Dalton's atomic theory was the first complete attempt to describe all matter in terms of atoms and their properties. Now are the postulates of John Dalton. According to him, all matter consists of indivisible particles called atoms. Atoms of the same element are similar in shape and mass, but differ from the atoms of other elements. Next is, atoms cannot be created nor destroyed. And atoms of different elements may combine with each other in a fixed, simple, whole number ratio to form compound atoms. Next are his drawbacks. The indivisibility of an atom was proved wrong. An atom can be further subdivided into protons, neutrons, and electrons. According to Dalton, the atoms of the same element are similar in all respects. However, atoms of some elements vary in their masses and densities. These atoms are different in masses are called isotopes.
Boom! So next we have J.J. Thomson.
The next scientist is J.J. Thomson, a physicist, an academic, and a teacher. This is his atomic model. Now for his postulates. According to him, an atom consists of a positively charged sphere with electrons filled into it. The negative and positive charge present inside an atom are equal, and as a whole, an atom is electrically neutral. Next is, Thomson's model of the atom was compared to plum pudding and watermelon. He compared the red edible part of the watermelon to positively charged spheres, whereas the seeds of watermelon to negatively charged particles. His drawbacks. His model of an atom failed to explain how a positive charge holds the negatively charged electrons in an atom. Therefore, it failed to explain the stability of an atom. Next, his theory also failed to account for the position of the nucleus in an atom. Last is, his model failed to explain the scattering of alpha particles.
And Ernest Rutherford.
Was conducted by Ernest Rutherford, a physicist from New Zealand who spent most of his career in England and Canada. In his famous gold foil experiment, Rutherford fired a thin beam of alpha particles at a very thin sheet of pure gold. Alpha particles are helium nuclei and they are given off in a various radioactive decay processes. In this case, Rutherford placed a sample of radium, a radioactive metal, inside a lead box with a small pinhole in it. Most of the radiation was absorbed by the lead, but a thin beam of alpha particles escaped out of the pinhole in the direction of the gold foil. The gold foil was surrounded by a detector screen that would flash when hit with an alpha particle. This is Rutherford's postulate. Rutherford's gold foil experiment showed that the atom is mostly empty space with a tiny, dense, positively charged nucleus and were concentrated in a very small volume within an atom. His drawback was Rutherford's atomic model failed to explain about the stability of electrons in a circular path.
And next, we have Niels Henrik David Bohr.
In order to explain the stability of an atom, Niels Bohr gave a new arrangement of electrons in the atom in 1913. According to Bohr's model of hydrogen, the electrons could revolve around the nucleus in only certain orbits, or the energy levels around the nucleus. This is his atomic model. His postulates, electrons occupy only certain orbits around the nucleus. Those orbits are stable and are called stationary orbits. Each orbit has an energy associated with it. The orbit nearest the nucleus has an energy of E1, the next orbit energy E2, and so forth. Energy is absorbed when an electron jumps from a lower orbit to a higher one, and energy is emitted when an electron falls from a higher orbit to a lower orbit. The energy and the frequency of light emitted or absorbed can be calculated by using the difference between the two orbital energies. His drawbacks are, Bohr model could not explain those atoms which have more than one electron like lithium and helium. This model was applicable only for those atoms which have one electron. Bohr theory explained only spherical orbits. There was no explanation for elliptical orbits. This model failed to explain Zeeman effect and Stark effect. Bohr model could not explain the uncertainty principle of Heisenberg. Bohr model was not related with classification and periodicity of elements. And lastly, by using Bohr atomic model, one can explain the intensity of spectrum line. Bohr was the first to recognize this by incorporating the idea of quantization into the electronic structure of the hydrogen atom, and he was able to thereby explain the emission spectra of hydrogen as well as other one-electron systems.
We also have Schrödinger and Heisenberg.
Erwin Schrödinger and Werner Heisenberg. They took the Bohr atom model one step further. They used mathematical equations to describe the likelihood of finding an electron in a certain position. This atomic model is known as the quantum mechanical model of the atom. Unlike the Bohr model, the quantum mechanical model does not define the exact path of an electron, but rather predicts the odds of the location of the electron. This model can be portrayed as a nucleus surrounded by an electron cloud. Where the cloud is most dense, the probability of finding the electron is greatest, and conversely, the electron is less likely to be in a less dense area of the cloud. Thus, this model introduced the concept of sub-energy levels.
And lastly, we have James Chadwick.
James Chadwick. Chadwick is best known for the discovery of the neutrally charged particle called the neutron. He found the neutron when he put an excessive charge into an atom. Some of the particles remained unaffected. He named the particles neutrons because they had a neutral charge. His discovery of excessively charging atoms also led to discovering that he could split heavier elements like uranium-235. This discovery was key to the development of the atomic bomb. These elements are located on the bottom of the periodic table.
Like the corner